students, and welcome back to our next module of 3D geometry. Here we are going to study direction cosines of a line, students. So let us start our studies. Now before this module we know that what are direction angles of a line, right? So with the previous module concept, let us continue. Let's consider a line L having direction angles alpha, beta and gamma. So let us see, there is a line in three-dimensional space which makes angle alpha with x-axis, beta with y-axis and gamma with z-axis. Now students, with this alpha, beta, gamma, let's try to find cosines of these angles, and they will be cos alpha, cos beta and cos gamma. Right, and these values, that is cos alpha, cos beta, cos gamma, give us new definition called as direction cosines. So let us see what are direction cosines. If alpha, beta, gamma are angles made by line, then cosines of these angles, that is cos alpha, cos beta and cos gamma, are called as direction cosines of that line. Alright students, now these values are denoted by LMN. So if alpha, beta, gamma are direction angles, then we say therefore L is cos alpha, M is cos beta and N is cos gamma. So here we see the definition of direction cosines. Now once we know direction cosines, let us try to produce direction cosines of coordinate axis. Okay students, so let us go to coordinate axis. We have studied direction angles of XYZ axis, and they are, there was a table which gave us line and alpha, beta, gamma. So x-axis has direction angle 0, 90, 90, y-axis 90, 0, 90, and for z it is 90, 90, 0. Now students, we know direction cosines are nothing but just we take cosine of each angle. So direction cosines for x-axis are alpha 0, beta 90, gamma 90 will give us cos 0, 1, cos 90, 0 and cos 90, 0. So we put result here for x-axis 1, 0, 0. Okay. Similarly, for y and z axis, student, we calculate for y-axis it is 0, 1, 0 and for z-axis cosines are 0, 0, 1. Okay, so this table gives direction cosines for coordinate axis. Alright, let us proceed. Now students, we know that if line is parallel to x-axis, then its direction angles will be same as x-axis, correct? So we have seen this in previous module that when lines are parallel, their direction angles are same. Alright, now if direction angles are same, we can say when lines are parallel, their direction cosines are also same. Okay, now we have to remember this for problems. Okay, now once we calculate direction cosines for coordinate axis, let us go to vectors. Let's consider two vectors OA and OA dash in our three-dimensional space. So here is XYZ axis with two vectors OA and OA dash. Okay students, now once we have these two vectors, for vectors OA and OA dash, the direction angles are, for OA dash it is alpha, beta and gamma, and for direction angles of OA dash we have pi minus alpha, pi minus beta and pi minus gamma. Okay, so once we have direction angles of these two vectors, let us calculate direction cosines of OA. So for vector OA, the direction cosines are cos alpha, cos beta, cos gamma, and for OA dash vector we have direction cosines cos of pi minus alpha, cos of pi minus beta and cos of pi minus gamma. Alright students, so if we say LMN for OA vector, then for OA dash vector we say it is minus L minus M minus N, because cos of pi minus alpha is minus cos alpha. Right students, now if you see in the diagram or in the three-dimensional system, OA and OA dash vector are opposite vectors but they are along the same line. That means, to summarize, we can say for any line in three-dimensional space, the direction cosines are plus or minus L, plus or minus M, plus or minus N. Alright students, so here we finish study of direction cosines. Thank you.